Welcome back, KSDS scientists. Today we're going to talk about how to calculate percent error. So in previous years of science, you've been expected to discuss sources of error at the end of your lab report and ways to improve it, but we actually want to go a step further in 8th grade science and be able to quantify how much our results were off from what they should have been, and that is called percent error. So here we have the formula for percent error. So percent error is equal to the theoretical value minus the experimental value divided by the theoretical value. And then you'll notice that around this entire fraction are absolute value bars, meaning you would take the absolute value of whatever came out of here times 100 to make it a percent. So what do I mean by theoretical value? Well, theoretical value, other ways to think about it are it's the actual value. Sometimes it's a known value that you're kind of aiming for, or it's the true value, and we'll go through some examples. Whereas the experimental value is the one that you came up with in your experiment or that you observed. So let's go through how we would do this for our Barbie Bungee as well as in a couple of other situations. So for our Barbie Bungee lab, you did one of two things when we went out and did our bungee jump. If you didn't get the correct number of rubber bands, you either figured out how many centimeters you were off by, or you figured out how many rubber bands it should have been. So I'm going to show you how you could use either of those things to calculate your percent error. So let's start with what I think most people did, which was determine what the correct number of rubber bands should have been. So let's say that you got that the correct number of rubber bands should have been 26 for your Barbie. So this is the correct number of bands. Now this is not the same for every group. It depends on the weight of your Barbie. I know different groups came up with different correct number of bands. So since this is the true number of rubber bands, this is what I would plug in for my theoretical value. This is what it actually should have been. My experimental value is what my group predicted, what all of our data, when we plugged it into our graph and came up with that equation and solved the equation, what we thought it was going to be. So let's say that my group thought that it was going to be 24 rubber bands. So this is what we thought. So now I would plug these numbers in. So percent error would be equal to 26 minus 24 divided by 26, and I would take the absolute value of this, although it's a positive number, so I don't really need to do anything to it, times 100. So it would be equal to 2 divided by 26 times 100. Let me just grab my calculator. And I would get a percent error of approximately 7.6 something percent. So actually let's round it to about 8%. Since this number 2 only has one sig fig and I'm doing division, I'll make my answer only have one significant figure too. So that would be my percent error. Now let's say that I chose to do it a different way. Let's say I chose to figure out how many centimeters I was off by. So let's say when I attached these 24 rubber bands, my Barbie was short by 30 centimeters from the floor. So in that case, my percent error is equal to the theoretical value in this case. The correct value would be the perfect jump, which is 453 centimeters, right? The exact height of the Berman lobby. And then I subtract what my group got, which was 400, and if we were off by 30, it must have been 423 centimeters divided by 453. So it's the 30 centimeters I was off by divided by the total number of centimeters. Again, theoretically, this is the absolute value, although if it's a positive number, you don't really need to worry about it, times 100. And so in that case, my group, divided by, if this was my group's data, we would have had a percent error of about 7%, when I round it to have just 1 sig fig. It looks like here I can maybe have either 1 or 2 sig figs depending on how certain I am about that 30 centimeters. So that's how you would calculate percent error for your Barbie Bungee lab, and you're going to be doing that today. Now I just want to show you a couple more examples really quick because I'm going to expect you to be able to calculate percent error in other lab situations, and there is going to be a question on your upcoming quiz to make sure that if you were given some data, you could calculate percent error for it. So here's a physics example that might be similar to something that we encounter later in the year, although not exactly the same. So it says a 20-pound bowling ball should take 1.36 seconds to fall from the top of a 2-story building, but a group of students who is doing an experiment measure that it takes 1.5 seconds. So we could calculate what is these students' percent error from the true or theoretical value. So again, since this is what it should take, my 1.36 seconds, that's going to be my theoretical value. Whereas 1.5 seconds, that's the experimental value. That's what the students came up with in their experiment. So percent error is equal to 1.36 minus 1.5 divided by 1.36. Now this is one of those cases where those absolute value bars do matter because you'll notice this is going to give you a negative number. And so by doing the absolute value, we make that positive times 100. So let me do the math really quick. And I get a percent error of about 10% in this situation. And here's an example from chemistry that might be something similar to what you've encountered last year when you were doing chemistry, or will encounter for sure in high school chemistry. So let's say you're doing a reaction and that reaction is supposed to yield 171.9 grams of product. That's what it's expected to, or what it should yield. But instead, in the lab, it only yields 154.8 grams. So what is the percent error? So again, this is what it should have been, and so that's my theoretical, whereas this is what it actually ended up being in the experiment. So that's my experimental value. So to get my percent error, I would do 171.9 minus 154.8 divided by 171.9 times 100, and I would get 171. About, once again, about a 10% error, although I can have some more sig figs in this situation because all of these numbers have 4 sig figs. So I actually, it could say it's like a 9.948% error in this lab. So these are some examples of how you may encounter percent error, and now you're ready to go calculate your percent error for your Barbie Bungee. Thanks for watching.